Hi, welcome to the Section 1-7 notes. This is on midpoint and distance formula. I'm going to do things a little bit different this time. I'm still getting used to writing on my computer screen with the stylus, and with the amount of space I have, I'm just not sure how great that would look with the space I have. This one has more work and stuff to it. So this time I'm going to try just talking through it, kind of highlighting things and starring things as I go, and hopefully I can kind of explain my work, and that will help you out. So first of all, we're talking about finding the midpoint on a number line. That's what we have going on over here to the left. Okay, so if you focus on that first, then it says the coordinate of the midpoint is halfway down, halfway between the coordinates of the other 2 points. In other words, the coordinate of the midpoint is the average of the coordinates of the endpoints. And right underneath that, it says that the coordinate of the midpoint of a segment whose endpoints have coordinates A and B is A plus B over 2. And again, you've taken the average of things many times. You add up the terms and you divide by however many there are. So in this case, you're adding up 2 things and dividing by 2. And we'll see an example of that in a moment. So if you have 2 points on a number line, you're just finding the exact middle spot between those 2 points. If we look over here to the right, this is talking about a coordinate plane finding the midpoint. So here it says the coordinates of the midpoint are halfway between the coordinates of the endpoints. In other words, the coordinates of the midpoint are the average of the x coordinates and the average of the y coordinates of the endpoints. So, you can see here it's basically the same thing as the a plus b over 2, but you have to do it twice, once for the x's and once for the y's. So we'll see an example of that in a moment as well. So let's get this moved up here. So if we move it up just to see example 1, over here on example 1a, it says that segment AB has endpoints at -4 and 9. What is the coordinate of the midpoint? So you can see I use this formula from up above, and I plugged in my -4 and my 9 because those are my endpoints. And I did -4 plus 9 over 2. And if I go and do -4 plus 9, I get 5. And so my midpoint is 5 halves. I could think of that as a fraction, or if I want to divide 5 halves, I get 2.5. If I showed you this number line below just as a check, I think it is a good idea to check to make sure your answer makes sense. So you can see here, I made a number line. Again, always want to have 0 as a reference point on the number line. I plotted -4 to the left of the 0, and I plotted the 9 to the right. And here I tried to make my spacing accurate so that my midpoint looks right. I didn't just, randomly put the -4 and the 9 on the number line. I went ahead and counted that. So when I plotted point A at -4, you can see I did that right here. And you can see I plotted the 9 over to the right of the 0 and labeled that B. And then I plotted my midpoint at 2.5 just to check that it looks right. And if I look at that, then yes, that star looks like it's halfway in between A and B. So that gives me confidence that I probably found the midpoint correctly. Another way I could check my answer is I could count the spaces from A to the star and count the spaces from B to the star, and I should get the same thing if it's technically right in the middle or at the midpoint. Okay, if we look at B, it says segment EF has endpoints at E is at 7, 5, and F is at 2, -4. What are the coordinates of the midpoint? So you can see here, I went ahead and plotted E over here at 7, 5. I plotted F over here at 2, -4. And to find the midpoint, you can see I used the midpoint formula that was up above on the notes. So I'm basically doing what I did on A, but I'm taking an average of the x's and an average of the y's. If it helps you to label your x values, label one of them x1, y1, and the other one x2, y2. That can be helpful when you're trying to use the formulas. And so I want to average the x's. So you can see I took 7 and 2 and added them up and divided by 2. And then I took the y's, the 5 and the -4, added them up and divided by 2. And I ended up with these fractions, 9 halves and 1 half. If you don't like the fractions, though, you can just divide. 9 divided by 2 gives you 4.5. and 1/2 is the same thing as 0.5. If you take the time to plot that point on your coordinate plane, to the right 4.5, up 0.5, you can see here is the midpoint, and it does look like it is right in the middle of E and F. So that gives me, again, confidence that I found that midpoint correctly. If I plotted my midpoint and it was out here, then I would really think something went wrong and I need to go back and check my work. All right, moving right along. So now if we look at example 2A over here, it says segment AB has an endpoint at 2 and a midpoint at 5. What is the other endpoint? So this one's kind of switching thing on us. It's saying the endpoint is at 2, the midpoint is at 5. What's the other endpoint? So a little different. So you can see I drew a number line. I went ahead and plotted the one endpoint at 2. I plotted the midpoint at -5. And it wants to know what the other endpoint is. Well, if this is the midpoint right here, if that's the middle, and one endpoint is to the right, and if I want to see how far away it is, I can count 1, 2, 3, 4, 5, 6, 7. And the other way is then I can count 7 going the other way. 1, 2, 3, 4, 5, 6, 7. And I can put my new dot here. And then I need to actually name where that spot is. And if I'm going to name where that spot is, I have to go back to the origin and then go in reference to that left, which is -12. And so that's my answer there. There's other ways you could do it, but I think that makes sense to most people. All right, keep on trucking here. Now, this is one that tends to be kind of tricky for people, okay? It's where they're giving you the midpoint, and they're giving you one endpoint and you're finding the other endpoint. But the thing is here, this is on a coordinate plane, not just on a number line, so it makes it a little more tricky. There are actually 3 methods that sometimes people like, okay? And you just need to, I'm going to show you all 3. I would like you to write down all 3. And then you need to get really good at one way of doing that, okay? You need to decide which way makes the most sense to you, and then you need to keep practicing that so you can do it. So you can see here that one way to do it is graphing. And so I went ahead and graphed the midpoint at -2, 1. So you can see here, this is the midpoint, and I labeled it as the midpoint. You're going to keep track of what you're doing. It says one endpoint is -5, 7. So here's the other point. There's my -5, 7 and my endpoint. And then I need to find where the other endpoint is, okay? And again, if I see how far it is from this endpoint to the midpoint, and you can see I went down 6 and to the right 3, then the new endpoint has to be the same amount, down 6, right 3, to get my new point. And then I can figure out where that actual point is coming from the origin, and I can see it's to the right 1 and then down 5. So that's how we get that answer, making sense of it. It's almost kind of like slope, doing rise over run or something like that. So the second method is the up-down way. I would say probably most people like to do it that way, just as it's shorter and less work. But you just have to make sure you understand it. And if you end up understanding the algebra better and you like algebra better, then feel free to do it that way, even though it's a little more work. You want to do what makes most sense to you. So you can see if you're doing this up-down way, what I like to do is write my midpoint first. It gave me its -2, 1. And then it gave me an endpoint, which is -5, 7. And then what I'm trying to find is the other endpoint. So without even graphing or anything, I can just look over here and say, okay, if I start at the middle, at the midpoint, and I go -2 plus what will give me this number, okay? And plus or minus, and in this case, it was -3. If I go -2 minus 3, I end up with -5. So if I started at the middle and went up to get to one endpoint, then I want to go that same amount down to get to the other endpoint. So you can see I added 3. So if I think of what -2 plus 3 is, it's this 1. Okay, if I come over here to the right side and look at the y values, I can say, okay, this 1, I can add 6 to it to get 7. And so if I go the other direction, if I went up to get 6, then if I go down, I'm going to subtract 6. So 1 minus 6 gives me -5. And that's what we end up with there. And that's, again, the same answer I got with the first method is 1, -5. All right, the last method I have is the algebra. And you can see I wrote the midpoint here in the middle, -2, 1. I wrote one endpoint, -5, 7. And over here, I kind of left my parentheses blank and said that's the other endpoint. All right, I went ahead and labeled my points. For the midpoint, I labeled it XM, YM, just so I didn't lose track of everyone. On over here, I labeled the other endpoint -5, 7, and I labeled it X1, Y1. And then the other endpoint, I labeled X2, Y2. Okay, so you can see I wrote down the formula here. It's basically just taking an average of the x's to get the best x value. And so you can see that I need to solve for the x value that's missing over here. So you can see I have xm for the midpoint is equal to x1 plus x2 over 2. And so you can see here that I plugged in -2 in for the xm. And then I plugged in the -5 in for x1. And then the x2, I don't know, so I left it as x2. And then the formula says it's dividing by 2. You're dividing by 2. And so if I want to solve this, because it has a fraction, I can multiply by 2 on both sides. That's where this comes from and this comes from. I'm multiplying by 2 to solve. When I do that, on the left side, I end up with -4. On the right side, my 2's cancel out. And I'm left with -5 plus x2. From there, if I go and add 5 to both sides, then I end up with 1. So that is the x part of my ordered pair. All right, if I do the same thing for the y's, you can see I've got my formula for taking an average of the y's on the right. You can see I plugged in my y part of the midpoint is 1 is equal to 7 plus y2 over 2. And then I'm multiplying by 2 on both sides, which on the left side gives me 2. On the right side, the 2's cancel out. And I'm left with 7 plus y2. And then I went ahead and subtracted 7 from both sides to get the -5. So here is my my other endpoint, 1, -5. And again, the 3 different methods all gave me the same result. Okay, from there, we've got some definitions here and formulas. It says we already know how to find distance on a number line. We talked about you can count the spaces, and there's some other methods we talked about. But on a coordinate plane, we may not be able to count the spaces. If the line is at a diagonal, that's going to be a problem because we can't count. And it says, and each point has an x and a y coordinate. So it says, how can we find the distance from A to B on a coordinate plane? In other words, how can we find the length of AB? And think, if you know 2 sides of a right triangle, how do you find the third side? So the Pythagorean theorem is something I know you've used before, but that's what we're talking about here. If you have a diagonal and a coordinate plane, you can make a right triangle out of that. You can count the horizontal and vertical to use that Pythagorean theorem to find the length of the distance. The formula for that is a squared plus b squared is c squared. And this is just a formula that comes in very handy, and it's one that most people can remember, which is good as well. To find the distance between 2 points on a coordinate plane, you can also use the distance formula, and I have that here. The distance formula is equal to x2 minus x1 squared plus y2 minus y1 squared, and then you've got the square root of all of that. It's really just a different version of the Pythagorean theorem. On another day for honors, we'll show how to derive that, but for the time being, just know that you technically can use the Pythagorean theorem or distance formula to find the length or the distance of 2 points on a coordinate plane. The thing is the distance formula is not given to you like on the test. So if you want to use it, you need to remember it. If not, then you would just use the Pythagorean theorem, and most people don't have trouble remembering that one. So if you look below, you can see that I've worked out example 3. And so let's go through that, or if you're already familiar with Pythagorean theorem and distance formula, maybe you want to try that on your own and then see if you get the same thing I do. But on example 3, it says find the measure of AB or the length of AB, and they're giving some ordered pairs. So I went ahead and plotted the ordered pairs. At A is at -3, -4, and B is at 5, 2. And you can see I'm looking for C. And you can see, I'm trying to find out how long this is, but you can see that I made a right triangle out of that diagonal. I'll use a different color. Okay, you can see that, here's the right triangle that I'm dealing with. And, again, I can figure out how long this bottom red line is by counting the spaces. It's like a number line, 1, 2, 3, 4, 5, 6, 7, 8. I'm not allowed to count along the diagonal, but I can count in the horizontal and vertical. So I got 8 here. You can see I count 1, 2, 3, 4, 5, 6. So I got 6 here. And now I can plug that in Pythagorean theorem. Remember, anytime you have a right triangle, the two sides that make up the right angle go in for A and B, your 8 and 6. And then the hypotenuse that's across the right angle goes in for C. You can see once I squared those, I get 64 plus 36. Add those together to get 100. And when I take the square root of both sides, you can see I get 10. Using the distance formula, you can see I plugged in my x's. I have 5 minus -3, and that's in parentheses squared. And then I plugged in my y's, 2 minus -4 squared. And once I did that, I got 8 squared plus 6 squared. And then, I saw from there, I ended up with square root of 100. That gives us 10. Okay. Example 4 is very similar to that. I would pause the video and go ahead and try that just so you get the practice of doing Pythagorean theorem and distance formula on your own. The only difference here on example 4 is the directions say to leave your answer in simplest radical form and round to the nearest tenth. So if you don't know how to do that part, then you can kind of listen to that review. That's something you would have done in algebra, but it's probably been a while. So if you don't remember how to do that part, just get as far as you can with the Pythagorean theorem and distance formula, and then we can talk about that in a moment. Okay, so go ahead and pause that and try example 4. And okay, welcome back. You've tried it. So then let's go ahead and check through that. So you can see our plotted points U and V. I drew my diagonal, and I need to find out how long it is. And you can see I wrote down my Pythagorean theorem. You can make a right triangle out of that. And again, you can count the spaces. From here to here is going to be 5. From here to here is going to be 10. And you can see I plugged those in Pythagorean theorem. Once I started working it out, I ended up with 125 is equal to C squared. And then when I took the square root of both sides, I had to think, is there a perfect square that goes evenly into 125? And there is. It's 25. And I had to think 25 times what gives me 125? And it's 5. So then I can take the square root of 25 and get 5, but I can't take the square root of this other 5, so I'm left with 5 square root of 5. And if you plug that in your calculator, you can round it to the nearest tenth, which is 11.2. So this way is leaving it in simplest radical form, and this way is leaving it rounded to the nearest tenth. You can see when you start working out the distance formula over here, when you plug your x's in here and go 5 minus -5, and when you plug your y's in here, -2 minus 3, you can see it starts looking a lot like the Pythagorean theorem. Here I ended up with 5 minus -5 is 10, so I'm going to square that. Over here I ended up with -5 in squared, which if you keep parentheses around that -5, then whenever you square that, you end up with a positive. So you can see I have 100 plus 125, or 100 plus 25, which gives me square root of 125, and now it's back to where we were on the left side here. I know that 25 times 5 is 125. I know that I can take the square root of 25 and get 5. And so you see, I left with the same thing I did when I used Pythagorean theorem. I reduced it down to 5 square root of 5 and the 11.2. So again, thanks for joining, and good luck with section 1-7.